Hi students, in this video I am going to explain about the solid state. So before entering into the solid state, first of all we have an idea about what you meant by solid, and the word solid comes from which type of substances. Means first of all the solid, the word it will comes from the word matter. So what is matter here? Matter is anything which has occupies space and mass. Space and mass is known as a matter. So in this matter is consist of mainly three parts, that is known as solids, liquids and gases. Solids, liquids and gases. There is a lot of difference from a solids to the liquids, liquids to the gases. It depends upon the nature of arrangement of constituent particles. Here the constituent particles, in the sense atoms, ions or molecules, are known as a constituent particles, and as well as it depends upon the nature of binding forces. In each of them. Like solids, the nature of binding forces will be different from that of the liquids, and as well as on here gases. So all the concepts are included in the formation of a nature of a matter in solids, liquids and gases. But particularly we have an idea about now here what is solid state. Before knowing about the solid state, the main differences between solids, liquids and gases is nothing but the constituent particles and nature of binding forces. Here the nature of binding forces, in the sense it may be attraction or repulsion or interactions, we will be call it as one constituent particles and nature of binding forces, in the sense. At the same time here the main similarity between liquids and gases is both will have a capacity to movement or the tendency to flow. So that is the reason liquids and gases are usually known as here fluids, in the sense, because of that it can have a capacity to flow. So due to that reason liquids and gases are considered as fluids. So why it is called as a fluids? In the sense it tendency to flow. Then what about the solids? Solids do not have any movement, but they have a tendency to oscillate in their mean position. So what is the meaning of this sentence? It is nothing but one here. They can have a capacity to oscillate, means because for example here one solid molecule will be there and here one solid molecule will be there, in the sense they can have a capacity to oscillate in their mean positions only. They cannot flow from one place to the another place. Due to that reason solids will have a fixed positions. This is a major difference between solids, liquids and gases. So next concept is here characteristic of solid state. What are the characteristics of solid state? In this concept we will have a idea about how the solid are different from that of the liquids and as well as on gases. Here the first point, it is included in a solid state, that is on characteristics, that is they have definite mass, volume and shape. They have definite mass, volume and shape. It is in the sense they have particular mass will be there, and as well as in volume and also shape. Means particular shape it is having, particular volume and particular mass. They can consist of one solid state. As a similar case here, the intermolecular distances are short in nature. What is the meaning of this sentence? Because, for example, just we will consider here in a solid state the constituent particles are arranged like this. The solid state, the constituent particles have arranged. In this case, if you are considering from one molecule to the another molecule, the distance will be very short in nature. Due to that, intermolecular distances are very short, so that intermolecular forces are very strong in nature. Intermolecular forces are strong. Means we can understand very easily, whenever the molecules will go from will go away from one another, automatically you can see here, if for example the molecules will be like this, in the sense the distance will be somewhat larger when compared to this state. At this time the intermolecular distances are somewhat long, so that intermolecular forces will be less. So this is the meaning of that. It is depends upon intermolecular distances. Means if the particular substances exhibit intermolecular forces are strong, in the sense they have a short intermolecular distances. If they have a short intermolecular distances, they have a intermolecular forces will be very strong. If they have a large intermolecular distances, it is indicates that their forces will be less in nature, means weak in nature. Similarly, the another most important character here, they are incompressible. They are incompressible and rigid in nature. They have incompressible and rigid. Means solids do not have any compressibility in nature, because solids are one very strong in nature. At the same time, they have rigid in nature, means they have particular they do not change their shape and depends upon the particular substances. Due to that reason, we will call it as one incompressible and rigid in nature. And another, for last important characteristic is known as here their constituent particles. Their constituent particles, I have already explained that here. What are constituent particles? They may be included atoms, molecules or ions. So these are called as one constituent particles. These constituent particles have fixed positions, and can only oscillate about their mean positions. It is indicates that these constituent particles, it might be taken as the atoms, molecules or ions, will have fixed positions. They have fixed positions. They cannot move from one place to the another place, but they can only oscillate about their mean positions. Means if the molecule will be present here, in the sense they can oscillate in their about their mean positions only. So this is the characteristics of a solid state, and all these 5 characteristics are included in characteristics of a solid state. It is important for usually 2 marks question. The next concept is classification of solids. Solids are classified into 2 types, is known as crystalline solids and amorphous solids. Now we will have an idea about what are crystalline solids and what are amorphous solids and what are the characteristics of crystalline solids and amorphous solids. First we will have an idea about that. First type of solids, that is crystalline solids. Crystalline solids. So what are here crystalline solids? Then what are the characteristics? Now we will have idea about here now. So in this crystalline solids, the first most point is the name itself indicates that crystalline solids, it is indicates that they will consist of crystals, means they consist of here large number of small crystals. Large number of small crystals. They have definite characteristic of geometrical shape. They have definite characteristic of geometrical shape. So this is the first point. It is included in a crystalline solids, means they have a large number of small crystals and they have a definite characteristic geometrical shape, in the sense they particularly exhibit the shape. It will exhibit the shape in the sense we can have an idea about that. Here the constituent particles are arranged in an order wise. The constituent particles are arranged in order, means orderly arrangement of constituent particles. Whenever they have arranged in a orderly, automatically it will exhibit the particular geometrical shape. At the same time, another important point we will notice that they have long range order. So what is the meaning of here long range order? It is nothing but they have regular pattern of arrangement, of particles which repeats itself, periodically over the entire crystal. Means long range order, it is indicates that they have a regular pattern of arrangement of particles. Due to the arrangement of a regularly, it will repeats itself periodically over entire the crystal. Means in a crystal the particles will arrangement, it will appears in a regular way. At the same time the particles which repeats itself in a periodically. So that type of one meaning it is indicates that long range order. So at the same time, another for most important characteristics in crystalline solids, it is indicates that they have sharp melting points. they have sharp melting points. It is usually in a short formation, we can represent as MP. So they have sharp melting points. Means what is the meaning of here sharp melting points? It is nothing but here they do not change depends upon the temperature, means they do not have a depend upon the temperature in nature. So that type of nature is included in the formation of a sharp melting point. And another most important point we will notice here, these crystalline solids are anisotropic in nature. Anisotropic. What is the meaning of here anisotropic? This is in a short note answer here. Anisotropic, it is opposite to that of isotropic. Isotropic, it is exhibited by the amorphous solids. Here what is the meaning of anisotropic? It is nothing but here some of their physical properties, like physical properties in the sense they have included so many type of physical properties. Among those they have noticed some type of physical properties only, like which type of physical properties they have considered in the sense electrical resistance. They have considered electrical resistance or refractive indexes. Refractive indexes shows different values. They shows different values. So such type of a nature are called as a anisotropy in nature. Means anisotropy, aniso means it is not similar, means it will be different. Which type of a characteristics are different in the sense physical properties are differences, like electrical resistance are different, and as well as refractive indexes also shows a different values. So why crystalline solids are exhibit anisotropic in nature? Then which type of conditions it is going to exhibit anisotropy? Means there is having one particular reason here, means when it will arises here, this arises from different arrangement of particles in different directions. When they have arrangement will be different, automatically the particles also arranged in different directions. When they have arranged in different directions, they can exhibit the anisotropy in nature. So this is the very important characteristics. This comes under the one here. Anisotropy means what? In the similar case, what are the examples are comes under the one here? Crystalline solids, it is nothing but one, you can take it as sodium chloride crystals and quartz. These are the examples for a crystalline solids. Now we will have an idea about a second type of crystals are called as here amorphous solids. What are here amorphous solids? What is the meaning of here amorphous solids? Now we will have an idea about. So amorphous solids, the word amorphous is derived from a Greek word. So amorphous is derived from a Greek word. So what is the meaning of here? Greek meaning of amorphous, it is nothing but no form. Means these type of solids, it do not have any form, means it do not have any particular geometrical shape, in the sense it have a irregular shape. So due to that reason, we will call it as one here amorphous solids do not have any no form, in the sense it do not have a regular shape, so it do not have a definite geometrical shape. At the same time here, these constituent particles will exhibit which type of an order. In earlier we have idea about that long range order. Here it is exhibited as short range order. Short range order. What is a short range order? Means what? Here they have regular and periodically repeating pattern. Repeating pattern is observed over short distance only. Short distance only means we can observe the regularity and periodicity periodically arrangement of one repeating pattern can observe only in a short distance only. If we are moving in a long distance, we cannot observe the regular and periodical repeating pattern. So that is the reason these amorphous solids will have exhibit only short range order. Then another characteristics here they do not have any sharp melting points. It is in the sense they gradually soften. They gradually soften over a range of temperature. Over a range of temperature means whenever the temperature it will go some changes, automatically they will change their particular characteristic, particular nature. So it is depends upon the temperature nature. Temperature. Then next point, these amorphous solids will exhibit isotropic in nature. Isotropic. What is the meaning of here isotropic? It is nothing but we already known about that. Anisotropic means what? Here isotropic. Anisotropic means they have different physical properties, and here iso means same. So they have a same physical properties. When this type of an isotropic it will arise, it is nothing but here it do not have a no long range order in them, and arrangement is irregular along all the directions. So therefore the value of any physical properties would be same along any directions. So if the same physical properties it is going to exhibit it, such type of a nature is called as isotropic in nature. Then another most important characteristic we will notice in this case of amorphous solids is, if we will take liquids, amorphous solids, amorphous solids have a tendency to flow. Though very slowly. Very slowly. Therefore sometimes these type of amorphous solids are known as pseudo-solids or supercooled liquids. Means amorphous solids somewhat the tendency or similar to that of the liquid. So what is the meaning of here? Pseudo solids or supercooled liquids, it is nothing but however the liquids have tendency to flow, so similarly amorphous solids will have a very slow flow it is going to having. So that type of a nature is called as pseudo solids or supercooled liquids. So it is very important for a short notes question, so you can notice this important for 1 mark or 2 marks question, like isotropy, anisotropic, and as well as on here pseudo solids means what and supercooled pseudosolids or supercooled liquids. At the same time, if we are taking a crystalline solids, or comes under true solids. So what are the examples for amorphous solids? Is included glass, rubber, and plastics, and also quartz glass. It is comes under one glass example. These are called as one here example for amorphous solids. So next concept is the differences between crystalline solids to the amorphous solids. How they will differences characteristics from crystalline solids to the amorphous solids. Now we will have an idea about that. So the differences, it is included between crystalline solids to the amorphous solids. So first most differences between crystalline solids to the amorphous solids, it is indicates that they have definite characteristic. They have definite characteristic in the sense they will exhibit particular geometrical shape here. Geometrical shape. Because of that, they have a definite characteristics, means they have a regular shape in essence. Then what about the amorphous solids? It is included as they have irregular shape, so that they do not have a particular geometrical shape. So this is the first point, first difference. So next one, they melt at a sharp melting point. Sharp melting point, and they have a characteristic temperature. They have a characteristic temperature. Then here amorphous solids, they have gradually soften. They gradually soften over a range of temperature, over a range of temperature. Then next point here, they have definite and characteristic heat of fusion. Heat of fusion means particularly they have definite and characteristic heat of fusion in the sense, fusion in nature. Then what about here amorphous solids? They do not have a definite heat of fusion. They do not have definite heat of fusion. Heat of fusion. So we already have an idea about that. These crystalline solids are anisotropic in nature. Then these are exhibited as isotropic in nature, and these are known as true solids. These are known as pseudo solids, or another name supercooled liquids. Supercooled liquids. Another last difference we will notice here, whenever these crystalline solids when cut with a sharp edged tool, they split into equal pieces, and newly generated surfaces are plain and smooth in nature. So whenever they have a plain and smooth surfaces, they could exhibit the regular surfaces. They could exhibit regular surfaces. Then what about the amorphous solids? When we cut with a sharp edged tool, we will get a two pieces, but we will get irregular surfaces. So these are the some differences between crystalline solids to the amorphous solids. It is also very important for a short notes answer. So please notice all the points. So if you have any doubt, please comment.